Hello, welcome to the Mark Janad Show, the cybersecurity show. In this video, I'm going to break down this huge CVE linked to NVIDIA, right? The NVIDIAScape. But before I get into that, I'm going to talk about a little bit of what NVIDIA is, the container, etc. So the non-techie people can kind of get up to speed. So without further ado, let's get right into it. We're going dark. So NVIDIA is a leading American technology company specializing in the design of graphic processing units, also known as GPUs, and related computer hardware and software, especially for fields like, artificial intelligence, high performance computing, gaming, data centers, etc. Right? So NVIDIA was founded in 1993 by, please take a moment to hit the subscribe button and the like button. Please take a moment to hit the subscribe button and the like button. Jensen Huang, Chris, Malachowski, hopefully I'm saying that name right, Curtis Priam, and it's headquartered in California, Santa Clara to be exact. So the company revolutionized computing by inventing the modern GPU in 1999, which became foundational to both the video gaming industry and AI research. So NVIDIA's product lines are the GeForce GPUs for gaming and creative professionals, the professional GPUs for scientific computing, visualization, and industrial use, specialized AI and data center chips used in training and deploying AI models, and powering supercomputers, the Tegra SoCs for mobile devices and automotive systems, cloud gaming services such as the GeForce Now. So NVIDIA is the world's top supplier of discrete GPUs, controlling about 92% of the desktop and laptop graphics card market as of 2025. The company is fabless, meaning it designs its chips but relies on partners like TSMC for manufacturing. So NVIDIA now plays a central role in the AI boom, providing essential hardware for large-scale AI training and deployment, and is basically a dominant player in supplying chips for supercomputers. Now, as a result of surging demand in AI and data center hardware, NVIDIA's market capitalization surpassed $4 trillion in 2025, making it one of the most valuable companies globally. Now, NVIDIAScape has to deal with the NVIDIA Container Toolkit, right? And I'm going to basically break that down right now. So the NVIDIA Container Toolkit is a set of libraries and utilities that enable users to build and run GPU accelerated containers using container platforms like Docker, Containered, right? Podman, LXC, and Kubernetes, right? Its core purpose is to provide the integration needed for containers to access the full computational capabilities of NVIDIA's GPUs, including support for graphics and compute APIs, such as CUDA, OpenGL, Vulkan, OpenCL, NVDC, all that jazz. Now, the toolkits, includes a specialized container runtime and supported libraries that automatically configure containers to leverage NVIDIA GPUs as long as the host system has the necessary NVIDIA drivers installed. So this toolkit supersedes the older NVIDIA Docker 2 approach and is now the recommended method for enabling GPU support in containers, as it is more modular, flexible, and compatible with modern container engines. So it is essential for running GPU accelerated workloads like deep learning, machine learning, and scientific computing inside containers without needing to install CUDA or NVIDIA drivers within the container itself. You generally need a NVIDIA GPU with the correct drivers installed on the host system, the NVIDIA Container Toolkit configured for use with your container runtime, like the Docker. Once installed, containers can directly access the GPU via a command line flag for Docker, the --GPUs, supporting efficient deployment and management of GPU-intensive workloads in isolated environments. So that's NVIDIA. That's the NVIDIA container, which is linked to the CVE, the NVIDIAScape, right? So the CVE, let's get into the nitty gritty of this, this story and whatnot, right? So the CVE 2025-23266 is a critical vulnerability dubbed NVIDIAScape in the NVIDIA Container Toolkit, also known as the NCT, leading to container escape and full root takeover of the host in shared GPU environments. So the flaw is rated with a CVSS score of 9.0, critical, due to its low exploitation complexity and high impact on confidentiality, integrity, and availability. Now, the vulnerability type is the container escape due to misconfiguration in how the NCT handles OCI hooks, which is the scripts or binaries that run at specific container lifecycle events. Now, it's in regards to an exploit vector, a specially crafted container deployable with basically as little as a 3-line Docker file can exploit the vulnerability to bypass basically the usual container isolation and escalate privileges, allowing arbitrary code execution as root on the host system, right? So attackers breaking out of a container can attain full root access to the physical and virtual host, access, steal, or tamper with data or proprietary models from other tenants sharing the GPU infrastructure, cause denial of service, or launch further attacks across the cloud infrastructure. Now, the affected environments basically is most acute in multi-tenant managed AI cloud services where multiple organizations run containers on shared hardware, whether it's the Nvidia GPUs, which is widely used in the AI and HPC environments across major cloud providers. Now, in order for this to be successful from a hacker perspective, it has to have an adjacent network, right? The attacker needs access to the container execution environment, such as through a cloud tenant capability. Now, the privileges required, there's basically low typical for users allowed to deploy containers. There is no user interaction required. Now, the scope has changed, right? The exploit crosses container boundaries to affect the host system, right? So, Peter, you can put the associated vector on the screen, the AV. Please put that on the screen for the viewers. Now, that's the attack vector, right? The adjacent network, which is low complexity, low privileges, no user interaction, changed scope, high impact on confidentiality, integrity, and availability. Now, the cause of this, the root cause, basically the vulnerability arises from improper validation of OCI hooks during container initialization, enabling hostile containers to inject or override hooks and execute code on the host, right? Now, there is, proof of concept exploits that show a minimal Docker file is sufficient to achieve the host level root compromise. Basically, the full details, including exploit scripts and defensive checks, are basically presented in the technical breakdowns of Wiz and zero path security. Now, the products that are infected, again, all major versions of the NVIDIA Container Toolkit are reported as affected, including those shipped with the SUSE Linux Enterprise, the Red Hat, and various AI cloud service providers. Now, there are limitations and there are caveats, right? The vulnerability does not affect systems where untrusted users cannot deploy or modify containers. Exploitation requires some form of basically logical network adjacency, right? Which is access to the orchestrator's container, launch capabilities. Now, to fix the CVE 2025-23266, also known as NVIDIAScape, right? You must upgrade to the patched versions of the affected NVIDIA components, right? The NVIDIA Container Toolkit, you have to upgrade that to the V1.17.8 or later. The NVIDIA GPU operator, you have to upgrade that to the V25.3.1 or later. All versions prior to these are vulnerable to a critical container escape risk, which allows attackers to gain root on the host by exploiting how certain OCI hooks, in particular, one trusting unfiltered environment variables, basically handle environment variables from the container. So the exploit can be triggered by malicious container with a crafted LD_preload variable. Now, upgrade the toolkit and operate it, right? Basically, these releases are drop-in upgrades and do not require changes to the kernel or GPU drivers. Now, if you need an immediate patching, right, a temporary mitigation is to disable the affected enable CUDA compat, that's the OCI hook, or block deployments of images containing the LD_preload or suspicious OCI hook modifications. However, some reports indicate these workarounds can be bypassed and are not as reliable as a full patching, so keep that in mind. You want to search your container registries and running pods for images that, set to LD_preload or are derived from vulnerable NVIDIA images. You have to block or scan for such images, right? Enforce additional runtime controls such as the SE Linux or the App Armor to limit file system access from the hook path and restrict cluster admin rights to reduce blast radius. Now, after patching, you want to audit your nodes for signs of compromise, right? The unexpected host processes spawned from containered suspicious files, right? Then rotate the cluster credentials and rebuild affected nodes if the attack signs are, found. Now, the risk primarily affects environments running untrusted GPU containers and in most severe in multi-tenant cloud GPU environments. So that's what I have for today. Please take a moment right now to hit that subscribe button and the like button. If you want more videos like this and you appreciate this content, please let me know that by hitting that subscribe button and the like button right now. I appreciate your viewership. Stay safe and see you on the next video.